Okay viewers, so I'm trying to move on to my next meter. That's the 3-phase SDM with a dial type. There's my test meter I'm going to test it with. I've already got the potentials ready to go. It's got active in, active in, active in. I'll try and do a phantom load with these two. Both the same wheel speed, exactly the same characteristics, other than the readout, so let's see. 6.6 turns to that disc would be 1/10 on this one. And that should advance exactly the same, so to give me my reference. Yeah, let's see what happens. I might get this, yeah, anyway. Yeah, I count the that wheel speed and allow for the potential between the difference between the two. That'll be a way of determining the doing a phantom test on 3-phase meters. Anyway, let's get these wired up and ready to go. Yeah, potentials all ready to go. Correct colour coding is used, red, yellow and blue. Now just going to hook them up on the board, so you get your active in and your phantom in. Any one of the phase outs will do for the other side of the transformer, and jump out to here. Now I want to put them in series, I think, yeah. Got a bit rusty in my parallel loading them series there. I'll try them in series first. Parallel, they yeah, there's a bit of a difference between the two. Put them in series, they go the same. Anyway, I'll work it out again. Getting my phantom loading correct for doing these tests. I want to do it the energy saving way, so anyway, let's hook these up and get them going. It says here, check phase sequence and connecting. So you've got your red, yellow and blue, phase 1, phase 2, phase 3. That's your colour coding. Okay, I think I've got it sorted out now. Bit of a tricky bit trickier than I thought, this method here with 3-phase meters, because of resistances and stuff. Makes sense, one meter will go faster than the other. I've also noticed don't even have to connect the potential coils up and it still works. But something just clicked to me. The potentials, where the potential coils already connected. Just turn the light on. In here, there's a leak up that connects between there and that little terminal block. It just clicked to me now. I go, oh yeah, I don't need those little potential wires there. They already are connected internally. As you can see, there's a solid metal piece which joins the two connections together anyway. So I was wasting my time putting an extra little wire there. You don't even have to use those little things here. So there we are. So I go, duh. Anyway. I think I've got it right now, because that goes in there, second last of the phase in, the last phase in, second phase in. Because of the water resistances of the wires and one meter goes faster than the other, I had to fiddle around to get it to go right, so I think I've got it right now. I'll get the clamp meter out, I'll turn the power up. Yeah, the discs are going at the exact same speed. That looks much better. After about half an hour stuffing around figuring it out, but anyway, let's connect it up to, I'll crank it up to 60 amps. That's better. 60 amps going through that. 1 kilowatt hour test. That's better. Okay, yep, the notches of increments are moving at the same rate so far, that's good. Bit hard to see on camera here, these load wheels. Yep, they're both advancing at the same rate. Get that a bit straighter. Here we are. Well, if the light helps. Get some light on the subject there. Yeah, I think that helps. So far so good. Moving very slowly, but they're both going at the same rate. Beautiful, I go 1 kilowatt hour. Because they're slower, at 66.6 per kilowatt hour, slower meters, so this test's going to take longer obviously. But yeah, so we'll start, yeah. 6.6 revs is 1/10 of a kilowatt hour. It just doesn't have a 1/10 dial on it. But so far so good. the increments do match up between this increment on here and the increment on that little number 8 there. They're matching up quite well. Now one's going to be a bit faster than the other because it's measuring the potential, but you allow for that. Yep, so far so good. This one's got 298.9. Yep, yeah, 298. It's a good thing about dial pointer meters, make you think. Get your brain working. Yep, so far so good. Bit deceiving at first because you've got 2 different dial types, got to get your head around. But once you learn the increments and what these increments do, you actually figure it out that they actually are moving at the same rate. Yeah, 60 amps going through those little wires. There we are, we're working quite well. So far so good. Beautiful. I'm only pulling what? Barely an amp. A little over an amp as usual on the mains, so it's a good energy friendly way of testing these meters. Yep, they're both going quite well. I didn't start this bang on and this on the 0 either, so this was about here, about 200 watt hours behind. But you get the idea. They're both going at the same rate, so. Bit of bloody cat hair on the camera. Yep, so far so good. 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. Yep, they both moved 4 increments on the so they're both advanced exactly 400 watt hours so far. So far so good. Yeah. I don't think I bothered doing the whole 1 kilowatt hour test. This is already 5.5 hours long already. It's pretty much good. Get to halfway before I might do a roll over yet on this meter yet. So far so good. We get to exactly halfway in this one. Yep, that's good. This one's accurate. Beautiful. $46,178.5 kilowatt hours. We'll shut off power when that gets exactly on the middle increment there on this meter. Power off. That's exactly in the middle increment. Unplug that, safety first. That went 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, about the same on this one, but it's halfway between from where I started. So let's measure a bit of the potential. You allow for that, and that's it. That one passed the accuracy test. It's time to get it all cleaned up and make a bloody terminal cover for it. Okay, viewers, it came out quite well. I couldn't get the paint off though. Hairspray or terps wouldn't get it off. I didn't want to scratch or scrub it off either, so I went on to scratch into the glass. I got all that off, but here on the bake a lot and that. I was scratching it too much. But it came up a treat. Real nice. It needs a bit hard to get, but I'm not too worried about the slop of dust in there. That'll be alright. Shine it right up. Real shiny now. As Wayne would say, I feel the shine. There we are. As I was saying before, these are internally connected to your potential coils here. those bits in there are all internally connected to these terminal blocks, so you don't even need to put your wires in there. Bit of a duh moment, but anyway, passed the test. It cleaned up quite well. Hey Cat, just noticed it's an Emmco EMR ST. Emmco Watthour meter type STM 1974. Specs again, I'll read them out. 3 phase, 4 wire, 66.6 per kilowatt hour, 50 cycles, 10 to 60 amps, 3 times 240 volts. 1974. Yeah. This one has it printed on the glass as well. Very well made instrument. Anyway, I think I've run out of plastic to make a decent terminal cover. I'm going to have to dig out some more decent bits of plastic I can make a terminal cover out of. I'll do that another time. For now, thanks for watching.